Hello and welcome back to the Building HVAC Science Podcast, where it's our goal here to create better, more knowledgeable HVAC and building performance technicians, helping the two professions better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. Talking about buildings, we're talking about homes, we're talking about a journey from efficiency to humanity and design. We have with us in the podcast Lucas and Austin from Vali Homes. Austin starts off by sharing his experience with sustainable building practices, particularly highlighting the initial venture into constructing LEED Platinum level buildings to demonstrate that high sustainability standards can be achieved without excessive cost or complexity. Then talks about a general approach where typical construction starts with existing methods and adapts to earn additional points, which often leads to more expensive or less effective outcomes. Austin advocates starting from scratch, focusing on creating healthy, durable, and efficient buildings that people enjoy to live in, which always promotes long-term sustainability beyond just the mere certification goals. We talk more about the success of their approach, noting how they managed to achieve almost all possible LEED points quickly by reevaluating materials and construction methods comprehensively. And again, it comes back to best things in business often come from planning and feedback. The process has led to a realization that focusing on human-centric design and the logic leads to better overall results, surpassing just mere compliance with certification standards. And they emphasize the importance of creating buildings people can connect with, which not only meet but exceed sustainability benchmarks. Lastly, the conversation touches on broader implications of their work, discussing how placing humans at the center of design and construction leads to more meaningful and sustainable outcomes. They critique the tendency in construction industry to prioritize efficiency over human experience, drawing parallels to broader societal issues like the overemphasis on caloric efficiency in American food production. They also stress the importance of materials and building methods that respect both people and the planet, suggesting a focus on a human-first design inherently leads to better and more sustainable buildings. Okay, I've given you a great overview, or I thought it was great. Why don't you listen in as we speak with Lucas and Austin from Vali Homes about sustainable spaces, the journey from efficiency to humanity in design. Today, I've got a couple of guests here that reached out to help us understand the 5 factors of good building. And because HVAC and building science harmonize within the shell, within the building, I thought this was an important topic to cover. So welcome, Lucas and Austin.
Thank you so much. It's a pleasure to be here.
Thank you. So our listeners probably don't know you, but I did some research and I thought you had some really exciting and interesting things to talk about. So why don't you give us some background? We'll have Lucas go first and you tell us what brought you to the point where we're talking about the 5 factors of good building.
Sure. I will do the briefest summary I can of that. It's been a long family tradition now. My dad was the guy who started the first energy efficiency programs in California when he was a graduate student at Stanford University. And so I was born and raised in this space. Tried to rebel and become a field biologist, but then all the plants and animals I was studying were being destroyed mostly because of the way that we build buildings. So I had a bit of a personal crisis about what my career is supposed to be about. Asked my dad and he said, you should get into high performance building, green building, whatever term you want to use. There's been a lot of them. We like to call it good building at this point. Less debate there. Everyone wants a good building. So I got various degrees, physical-chemical biology at UCLA and a Master of Environmental Science, double master's basically with a green MBA at UC Santa Barbara. Moved to Seattle, ran a bunch of energy efficiency programs, started working for a company that designed and built passive houses. Shout out to Artisans Group. And had a really good time, learned a lot about this stuff, but then got extremely frustrated by our rather myopic focus on energy efficiency above all else, when really what we want is good building. And energy efficiency is a component of that. But we need to be very careful about how we deliver energy efficiency, in particular, which ingredients we use to deliver it, because the ingredients that we use have entire product life cycles that are often underexplored or not misunderstood, and results counter to what we're trying to achieve most of the time, such as extremely high carbon impact and major social justice issues. So getting very concerned about that. And wanting to find better materials, I joined a company called 475 High Performance Building Supply. I was their Western Regional Manager for 5 years, helped invent the smart enclosure system with them. Really wonderful experience. And then we moved to Arizona. My wife's a professor of anthropology and works at the U of A. And through moving to Arizona, I met Austin, who'd been on a somewhat parallel journey, getting to wanting to deliver good buildings. And we just started nerding out together a lot and like sending building science jokes to each other and stuff like that. So eventually it was like, we should probably work together. And the opportunity came up and we've been working together for the last couple of years now.
Very interesting. We used some products from 475 on the home that we built, the net zero home we built, just because they're not available a lot of places, especially 3 years ago. Interesting. Can you share with the listeners what 475 stands for?
It's a passive house heating standard, 4.75 kilobtu per square foot, because we decided to do things in imperial. There's a lot of debate around that as people who love building science, metrics, official units of science, but you got to translate to imperial so that the audience gets it.
Nice. Thank you. Austin, tell us about what led you up to the point we're talking today.
I had a little bit of an opposite approach. My background is in human health, exercise physiology, kinesiology degree, and was really heading into healthcare looking for preventative care, really just like how should we be actually living to live healthier, both mentally and physically. And long story short, I kind of ran away from a traditional healthcare industry because it was difficult to actually look at things preventatively. And everything was basically, let's wait till we have serious problems and then try and treat those. And if you want to be healthy, good for you. We don't really know what to do with it. So I was then looking for what is it that actually provides the most benefit to people or has the most impact on them from mental and physical health. And that's an actual industry that we can do something about. I've always been a design nerd, materials nerd, just really a science background in general. And that led me to housing. We spend so much time in buildings. They have so much impact, both environmentally, but also personally to us. And references to which industries came first in the world. Like the construction industry is like debatably the fourth industry ever invented. And so one of the longest running industries in the world and messed up on so many levels. So that got me into construction, into design, into housing, and really just trying to look at that holistically of how do we actually holistically build better buildings. And that's been a journey on really the micro level in a lot of ways. Like what are the small things that we're missing that amplify? What are the things that we've traditionally been doing that don't make any sense? Long story short, fast forward, we thought we would be doing development. We thought that would be the path. We just build something really great. It would be obvious to people. They would see it and be off to the races, and we'd be able to do a whole lot of development work. And so we do some development now. We do some consulting work as well. And I guess my personal approach is like, how many people can we affect and how much positive impact can we create through these different partnerships? So that's trades doing the work. How can we make their life better, get them better, healthier materials? How can we have better impact to obviously the people who live in these buildings? What does that relationship look like long term for them with their house? Will they have maintenance concerns? Really just what is the life cycle of housing and how do we make a better impact towards a better future of housing?
I'll go back to Lucas. What's the last year look like, either in terms of general theme of projects or maybe even a couple specific ones?
Absolutely. Everything we do orients around building science. That's the lead on everything that we do. Consulting work is what we do broadly all over North America, and it's how we have as broad of an impact as we can. And then locally, we do development to see how deep of an impact we can have on a given project. I've never seen anyone better than Austin at diving very, very deep into the details of something. And he's incredibly good at documenting all that research and everything. So part of why we do development work, maybe the main reason we do it, is it's applied research on how good materials actually work in our climate zone, which is a hot mixed climate. Fun fact, the Sonoran Desert's the only desert in the world with 2 rainy seasons. So we actually deal with a lot of rotten mold risk here. That really surprises people. It's Arizona. There's no way that there's rotten mold here. In fact, there's probably more rotten mold issues here than in Seattle because Seattle's cold and wet and then hot and dry during summer. We end up with a monsoon season, which brings a lot of heat and moisture together into buildings that are not designed to have sufficient drying capacity. So a lot of our work is around that, is around taking good materials that we know that work in other climates and experimenting with them on our own projects to make sure they work in this climate, and then applying that knowledge to help other people as well. Our most exciting project is the Vali Muse project. It's a missing middle type housing project. So it's 4 units down a little private street, private drive. Muse is a concept that comes from housing around England, especially in London. And the idea was to build a micro community of truly good buildings and really see how far we could push truly good. And the results have been exceptional. There's 4 absolutely gorgeous units. We got featured in the recent Rocky Mountain Institute report on life cycle carbon of residential construction as one of the leading examples of low upfront embodied carbon as well as low life cycle carbon, including operational carbon impact. So they're built to more or less passive house standard. They probably exceed passive house standard for our climate zone. And they have roughly a fifth of the upfront carbon that a typical building would have. And all healthy materials, every single thing in there is red list free. Austin's really the mastermind behind Vali Muse, so I should probably pass that to him to describe more.
Yeah, let's dig in.
But I will say we also do a lot of retrofit consulting. We just are meeting with some clients later today about an amazing opportunity to an old ranch house and turn that into an amazing family property. We really just love the work that we do. And it's everything from backyard cottages through developments, through remodels. We're working on some multifamily projects as well. We've been busy.
Very good. Austin, fill us in the details, but I also want to make sure the listeners understand what development means. So some of the shorthand, you're not using a tremendous amount, and then also the red list. So if you could give the definition of what development means for you and what our listeners should be paying attention to, and the red list, and then get on to digging into the Muse.
Development for us really is taking on the entire problem, I guess maybe is a good way to think about it. So often as building scientists, we get to, or as we're looking for a better term than consultants, for example, because the typical view of a consultant is like, hey, the smart people who come, show up, give us some information, disappear, and then make everyone's life more difficult. So for us, development is really important because we are putting ourselves out in the free market, taking every step of this project from purchasing a piece of land to what architects do we work with, what materials do we use, what trades are building this, how are those trades treated, how is this marketed, how do people understand it? And at the end of the day, there's nowhere to hide. So whatever you've created, it's entirely on us and the team we've assembled to create this thing. And then the world gets to judge it. I think at the core, that's what development is for us. And so that really helps our consulting work as well. Because when we're talking to a client, we say, hey, this material costs this much to install, or this is the process, or it's really easy, or it's really difficult, or whatever it may be. We're giving them that information from direct experience, from being in that problem 100%. So for us, that's really the real value of development. And then it also gets to become a showcase of sorts of this is the best thing. Like we're never doing development. We're terrible at making money at development because we're always taking it all the way. And so I think that was the early realization, like, hey, we'll be developers. It'll be great. We'll build this amazing thing. People will value it. It's a great business model. And then we're like, oh, when you actually take something to the end, it's a lot to comprehend and a lot to do. And so for us, development becomes, how do you actually get people to understand that? How do we now explain all these different pieces in a cohesive way? What materials are actually important in this overall system? So like Havelock wool would be an example where a lot of people don't want to spend the money to install that in their given project because like, oh, well, line item by line item, it's way more expensive than my fiberglass bats or whatever like the least expensive option is. And it's more difficult and I got to find it and I'm just not doing it. Whereas now that it's already installed in Muse, it's the gateway drug for people to understand more of what's happening at Muse and with building science in general. We've done a ton of open houses and we've got QR codes around the house of us explaining different features in the house so people can really connect with and understand like why this exists, not just what it is.
Havelock wool. Can you explain what that is?
Yeah. So it's actual sheep's wool. It's largely from New Zealand. Lucas can talk more about the company because he has more length of experience with them. But the short answer is it's an amazing product that's a byproduct from the fabric industry. So it's a secondary revenue stream for shepherds in New Zealand. It's produced by an amazing company called Havelock in the US. It's carbon negative by the time it gets to the site. It's a ridiculously good insulator with combined with other materials in the proper way. Actually, I'll let Lucas give a minute on maybe some more of the details of Havelock, and then I'll talk about how we used it at Muse.
Havelock wool is something I've been using for many years now, and Austin makes good points. It is expensive. It's a little complicated, and generally, we find that when people use it, they've considered it really well worth it for a couple of reasons. It's a good insulator, works well for soundproofing, that kind of stuff. People can feel good because it's net carbon storing, so that's a nice thing. There's a whole story around EPDs I won't get into right now about that, but wool itself is actually net carbon storing. And it's red list free is something we promised to circle back to. They have a red list free material, which means the red list is a comprehensive list of chemicals put together by a bunch of genius European engineers that the International Living Future Institute uses for their health certifications. So it's a comprehensive list of chemicals that are known to have negative human health consequences. And for a product to meet the highest levels of health standards, it should be red list free. That's the highest level of health standard that we're aware of. If there's other ones, please let us know. We'd like to use them. But that's the highest level that we're aware of. Another little neat feature, and I think we should tie into HVAC because we're on an HVAC podcast, so I'm going to pass that back to you in a second, Austin. But with the Havelock wool, it has a very high surface area as the fiber itself. Austin earlier had talked about how a lot of this work is at the micro level. That's a really important point we need to make. Performance occurs at the microscopic scale, not the macroscopic scale. And we often conflate different materials because they're like, oh, it's fibrous insulation. It's the same thing. But if you look at a fiberglass fiber under a microscope, it's a really boring rod. If you look at a wool fiber under a microscope, it looks like shark skin on steroids. It's a very, very different fiber, which gives very different characteristics. For instance, mold can't grow on wool. It's a very different fiber. Due to that super high surface area, it also has very good hygroscopic properties. So in other words, it can take on ambient moisture. If there's too high of a relative humidity in the building, the wool can adsorb onto the surface of the wool a ton of moisture because it has a very high surface area. Then when it gets too dry, that moisture can get released back into the building. For this reason, at Vali Muse, we left the wool exposed as much as possible, so we didn't put an air barrier over it, so that when there is excess moisture, it goes through the drywall, gets adsorbed into the wool, and when it's too dry inside, which happens quite often in Arizona, one of the big problems with housing here, the moisture can go back in. And when you combine that with the passive house levels of air tightness, the air quality that we have at Vali Muse, it goes down when you open the doors and windows. Out of a index score of 100 from Aware, it's usually 99 or 100. So one of our cheesy sayings is step inside for fresh air, because we can literally guarantee better air quality inside than outside at any given point.
So you mentioned the relative humidity reservoir that the walls provide and the Aware score. So it sounds like you're monitoring. Would Austin be the one to talk about monitoring, or you, Lucas?
We both love the subject. I'll just say that monitoring is something that should happen. It's very much part of our applied research. Like so much of building science is theoretical, happens in a lab, and it should be applied and measured in reality in real buildings, especially in your climate zone you're building in, right? So with that, I'll say part of Austin, if you want to bring up as an example of the work that we do, how we did the ERV at Muse.
I'll tell a little story of how we use more of this applied long-term, why this is important. So like the house I'm in right now, we had an Airbnb for 4 years before that. And we had some basic measuring of Aware, measures air quality, sensor pushes, some sensors in the walls and on the roofs and whatnot. We'd love to get into more measurement. We can get into some things we're looking at later if that's important. But what we learned is that really important in that feedback loop is what people are doing, how people feel in that space, what the house is doing, what's happening in that climate. So it's trying to get a more holistic view of this thing and then come up with really obvious conclusions. So what we found is when you gather the right amount of data and interpret it the correct way, there's not really a whole lot of nuance, like, oh, maybe it goes this way, maybe it goes that way. The decisions are pretty black and white. So for example, we've been building to fairly extreme air tightnesses, always under passive house, usually to more of a 0.4 ACH or so. And we've been using HRVs. That was our original hypothesis. This will be perfectly fine for our climate. And then we noticed And it is like the interior air quality is amazing. And we noticed subjectively from people coming on Airbnb, for example, that they'd come up with all sorts of really interesting observations. Like they'd message us after they've been here for a few hours or a few days. And it was always some version of, I feel really good in here. That's like a question. I know I feel good, but what's happening, right? And people have all these crazy, like, I heard Vegas pumps in oxygen to the buildings. Are you doing that? Are you drugging me somehow? Like, what's happening? And it turns out it's air quality mixed with biophilic design and just good design in general. So there's a lot of things happening cohesively. But back on topic, between that, through that experience, we learned that ERVs would actually be better for our climate than HRVs when we're splitting hairs. The winter interior humidity in buildings in Arizona tend to still get pretty low. Passive house with an HRV is still better than a typical building here, but it's lower than ideal. You swap that out for a well-designed ERV, and now your humidity is higher in the winter and it stays nice and your air quality is better. But probably more importantly, Lucas was talking about monsoons earlier, which is something that people who don't live in this climate don't really pay attention to. And we get all sorts of construction standards coming from elsewhere and showing up here. And we end up with all sorts of weird problems with heat and humidity at the same time, both in the building system, but also then in interior comfort. So we get heating and cooling systems that are designed to keep the house at 72 degrees at 107 degrees in Phoenix. But when it's 90 degrees and we have a monsoon, those systems generally fall totally flat and we end up with a bunch of really bad indoor air quality and really high humidity. So then build airtight, swap an ERV instead of an HRV, like very simple changes, but they end up with much better results. And then through that, we also realized CO2 levels, for example, there's plenty of studies now of how much effect high CO2 levels have. And so now, like at Muse, we're measuring CO2 levels and automating the fresh air. So the ERV runs at low speed all the time, but when humidity in bathrooms or CO2 throughout the house is elevated, it'll automatically boost the unit. So there's no interaction from people. They don't have to think about it. They don't have to be an engineer to live in the house, but their air quality and their felt experience is improved.
What's your threshold to trigger ventilation on CO2?
It's generally leave it like 700 or 800, but we automate that with a system called Luxone, which is also in our lighting system. And that's adjustable. So you can actually adjust it to kick on at a certain threshold and then kick off at a lower. Basically, we try to set it up more like an EV where you have this hardware software integration. So as we learn more over time, it's continuously adjustable.
And Austin, I think that's a really good point to give an example about how you collaborated. We collaborated, mostly you, with the electrician, the HVAC guy, et cetera, to come up with a way to manage the heating and cooling system, the ERV, with the system that we're using for the lighting, and the custom filter for it too, because the filters that it came with were not meeting our standard. So I think it's worth explaining a little bit about that.
For sure. I don't know what it is about ERVs and HRVs, why they all have to have comically small filters. If we could just get a real filter on one, that'd be amazing. Which comes down to that applied experience. We get these homeowners like, okay, I'm in this cool high performance Ferrari of housing, but like I have to own a stack of filters that I replace every month and I've got to constantly check and see when because it's crazy. So we end up using a 4-inch April air filter. Everything is hard ducted from the HVAC standpoint, and the 4-inch filter provides very little resistance and has a ton of surface area, so you don't really have to replace it very often. So now we have MERV 13 filtration before the ERV unit for the whole house, and then we have the same on the heat pump side. So relatively simple, common, straightforward things that provide a significantly better experience.
And all the ductwork is run in conditioned space, of course.
Let's get into those 5 factors.
Sure.
I will put a link to an article from Green Building Advisor, which you forwarded to me. I'll put that into the show notes.
Thank you.
One thing I'm going to home in now is something called the efficiency trap. And you alluded to that before, and I'd like to hear you expound on that a little.
Happy to talk about it. It's one of my favorite subjects. I mean, a lot of my career was focused around energy efficiency. After grad school, I started a building science division for a company called Allen Construction down in Santa Barbara. They're one of the original green building companies out there. It was a fantastic experience. But we were focused on energy efficiency above all else. And it led us to do a lot of things like installing a ton of spray foam insulation before we started collecting more data on that such as how long does it last? Why are people dressed up like they work for the CDC during an outbreak to install it? Not a good question to ask. What's the upfront carbon impact? How long is this going to take to pay back? Let's go measure the house a year later and see if the airtightness that we delivered up front is still there. Turns out mostly not. So I started noticing these flaws in putting efficiency above all else. But I continued focusing on it. It continued to be the main thing that our whole economy got caught up in. It's wonderful that we've been trying to do good things and help through efficiency. But if we all want to help, we need to look at real information and real data and understand the holistic impacts of the work that we do. That's a good introduction to why the 5 factors of good building became the main thing that we focus on as far as explaining the work we do and why we're making certain design decisions, material selections, et cetera, et cetera. But the quick efficiency trap circle, it's that somewhere in the 70s, we were like, oh no, we're running out of resources. Stuff's getting expensive. We need more control over our destiny. So let's make things efficient. And at the same time, there was this whole consciousness of we're getting kind of unhealthy in buildings. That's when like sick building syndrome started being, wasn't called that then, but it was being noticed. A lot of stuff started being documented. And there became this assumption that if we did efficiency, we would actually sneak in the rest of the green stuff too. And that was just made as a myth. And no one questioned that. So we kept doubling down and doubling down and doubling down on efficiency. And then we get to the point where there's passive houses starting to be everywhere. And we're like, yes, passive house, perfected efficiency, the world is saved. And turns out not so much, because if you build that passive house with a bunch of foam insulation, for instance, you have now created hundreds of years, in many scenarios, hundreds of years of upfront carbon impact that needs to be paid back. So a far higher life cycle carbon impact than a conventional building built with conventional materials. You've created a very airtight environment that contains a lot of toxins. So that isn't necessarily very good for health. You've created a system that's going to have a terrible time trying to dry. So you're going to have a lot of maintenance issues over time and maybe some significant rot and mold risk, depending on the details. And the factor that we've added into the mix too, that really should be probably the first thing we're talking about, is the social justice impacts of the materials that we're using. Is it fair to have people dress up and risk their lives to install insulation because we wanted to draw it on a plan set because it made our lives easier? Is that okay? Let's think about the whole life cycle of a product. That's the fundamental concept that led up to creating this thing we call the 5 factors of good building. Since I started with this subject about social justice, borrowing from my wife's anthropology world, there's a term called embodied injustice. So it's very similar to embodied carbon. That's why we're choosing to use that. And embodied injustice is the structural violence against people that is built into a product through its life cycle. So for foam insulation, think about everything from the negative politics and war for oil, the big chemical factories that workers get cancer and they poison communities and all this other stuff. That's all tied into the product life cycle. You cannot remove that from the history of that product, just as you cannot remove the life cycle of carbon impact from that product. So that's starting with 2 of the factors. One is embodied injustice. One of them is life cycle carbon impact. Other factor is efficiency and renewables. Efficiency should still definitely be part of the conversation, and renewables too, but it's not the only part of the conversation. And then comfort and health and durability and resiliency. So with us losing control of our climate right now, resiliency has become a necessary part of that conversation along with durability. How do we design for what we predict is in a more extreme climate, not just if we're using historical averages for our design decisions at this point, that might lead to some major failures because we're seeing more extreme events more often than before. So to go back through those again, durability and resiliency, comfort and health, efficiency and renewables, life cycle carbon impact, and embodied injustice. And we think about all these factors for every design decision we make, especially in terms of material selection. And 2 last things to wrap that up is we found if you design for efficiency first, you end up with a very high risk of other failures occurring. If you design for comfort and health, social justice, and low carbon, you end up with an exceptionally efficient building. That's the nice side effect of that work, and you guarantee success across those other factors because you've paid attention to them. The other thing is, anyone who's been in this industry understands this, we have buildings designed And then we get to this phase where we're about to go to construction documents, and people all of a sudden are like, what are we going to build this building out of? What insulation? What air barriers? What weather resistant barriers? What are all the performance details? Like, oh, what mechanical system's going in here? These are decisions that should be made at the beginning of a project, because it turns out the products, the materials themselves, one of our sayings is the ingredients create the results. It's just like a meal. And too often in our industry, we see an otherwise really good meal, let's say an amazing salad someone made, and then they find out that the meat is spoiled, but they still cook it and put it on the salad anyway. That's spray foam insulation going into an otherwise good building, for instance. It's not a good meal anymore, just as it's not really a good building. Like, one ingredient can really spoil the entire outcome of a building. And we really need to pay attention to the entire background of the products that we use. So that's our fundamental premise, is that the materials come first.
Very good. I will definitely put the link to that article there, because there's a lot more to it than what you said. And there's also a lot of links out from there.
There's decades of history and tens of thousands of buildings behind this. Yeah.
Very, very cool.
One concrete example was our first new build we built as Vali. We wanted to showcase what you could do without any real complicated or overly expensive products or processes. And the most obvious way to do that was to focus on LEED certification, because enough people understand LEED. And at the time, this was maybe 12, 15 years ago, it was assumed that building a LEED platinum level building was going to be expensive and complicated and need a bunch of specialized things. And so what we found through going through that process was almost everyone who went for the certification starts with what they're already doing and then looks for what they could change to pick off some points. And almost always you gain some material swaps, for example, were just beneficial, but sometimes you'd end up with a worse building. Almost always you'd end up with a worse or more expensive building overall. So instead, we just scrapped what was typical and just said, okay, if we were to start from scratch with what does a efficient, healthy, durable building look like? What materials are you using? How would we make sure the architecture is something that people connect with and actually want to live in and is going to remain here long term? Because it's not sustainable if somebody thinks it's weird and crazy and tears it down in 20 years. And then how is that buildable? What trades do we have, and how can we help educate those trades and actually give them better skills? Through that whole process, it became comical because we got almost all the possible lead points from the residential scale pretty quickly. I should say we went through all the different materials and construction methods we really could have possibly gone for. We had at one point like 3 foot wide by 7 foot long spreadsheet when it was printed off of all. We looked into SIP panels, we looked into containers, we looked into let's just look at all of it, pretending like we have no clue what we're doing. And there was some pretty clear answers out of that and some clear that doesn't really add up. And all the way through the running, I guess what we really found was that the right answers were obvious. There were building methods. There were things that made the architecture construction better. They improved everything all across the board instead of gaining one area and losing another area. And so through the whole process, we had our architect was like, well, if we scale back this thing, will we lose too many points and we won't get platinum? We're so far above platinum points at this point, it doesn't matter. Through that process, we found you could absolutely build, and we built Passive House later after that and looked at other certifications, and we eventually stopped building to certifications. That's where we came up with 5 factors of what's the holistically best thing that borrows from each of these or pieces from each of these, but puts humans in the center. And I guess what we found is that there are really more binary decisions. And if you focus on humans first and use logic along the way, you end up with a better result. Go figure, right?
Do you know Robert Bean?
Yeah. I mean, I don't know him personally, but I do know.
One of his quotes is, focus on people, better buildings follow. That's a rough interpretation of the quote. So you just said it right there. I mean, we could have started this podcast a long time ago. You got it. You nailed it.
We get so many things in construction and development that we lose track of people along the way. I guess a tangential example, and maybe more concrete example to the efficiency trap would be food in America, right? At one point, we had a caloric problem. People didn't have enough calories. And then, as we often do as Americans, we crushed that problem and created the Farm Bill and have tons of corn and corn syrup. And now, outside of some rare examples, very few people don't have enough calories, but we have an absolute massive problem around having too many calories with heart disease and diabetes and all this. And so we've done the same thing with efficiency. Efficiency was our original problem. yeah, we had a lot of carbon impact because buildings were inefficient. And so let's tear down all the old ones and build more efficient buildings. We've lost the whole point along the way and entirely forgotten about people and the experience of like why we have buildings. So I think that's really our goal now is like we are designing buildings for people, both the people who will live in the buildings, the people that build the buildings, and the people at large in the society or the world when we're considering climate impacts.
Just to add on to that, if you put people first and then select materials that put people first, you pretty much can't screw up the building. It's going to be at least a good building. Might be a low performance good building, and that might be what you can afford. In my case, I'm talking to you from a low performance good building right now because we are still saving up to make it a high performance building. But if you can do another certification along with it, if it's a truly good passive house or a pretty good house or a truly good LEED Platinum building, that's fine. But the materials have to come first, and the materials need to respect people and our planet. Another saying we have is construction's the art of managing chaos. It is a chaotic and difficult thing to design and build anything. And certifications are wonderful in teaching people how to build better, but they also do add typically some complication to that chaos. And people can really lose the point in trying to achieve a certain thing. Perfect quick example is a passive house I worked on in Vancouver, Canada, that was one of the coolest projects I've ever seen. But it was owned by an engineer who wanted to set a record for energy usage per square foot and switched from truly good materials to a bunch of spray foam and vacuum insulated panels and other stuff that have tremendously high carbon impact, and turned it from a project that would have been healthy and net carbon storing up front to a project with roughly a 300-year carbon payback that had major health and durability risks because they were chasing efficiency or chasing calories, if you will. It's pretty wild. So
I think just to add to some of that real quick, sorry, Bill, we need buildings that speak to humans also. It's one thing to get a bunch of engineering nerds building better buildings because they're like us and they want to get into the crazy details of things and have this perfectly optimized system. But one of the most rewarding things I've seen in development or even with custom clients as well, or whatever it may be, but just Michael Green had a quote once about building out of wood. And he said, I've never seen someone walk into one of my concrete and steel buildings and hug a column, but I see it frequently in a mass timber building. And we see similar things to that all the time. We've had people contact us, like we'll get published for a building meeting passive house standards or something. And then people will contact us and say, I just want to thank you for making a passive house that's beautiful, that's a place that people want to be. And we see that like Muse is an exceptional example because we went really over the top on having natural materials everywhere possible. And we see people connecting with that building all the time. There'll be all these people like, I hate modern design because they think of modern as this clean, sterile thing. And then they're in Muse. We have a bunch of materials we touch, but the railing is a special thing where we had a specific profile and it's made out of reclaimed walnut from a local furniture maker. And there's almost always somebody stopped in the stairwell, just like touching the rail, just rubbing their hands back and forth on the railing. Or the countertop is like a material you want to touch. So people sit there and they just rub their hands on the countertop while they're talking.
like a genie's lamp on the countertop. It's pretty.
We always joke like you walked in just like a Muse open house, you think we like drugged everyone in there.
People are walking around like, is it okay to feel this good? You're like, pretty entertaining.
Back to that Airbnb concept. Did you put something in the air? Are you doing something to manipulate people's psyche?
We put good air inside the building. I mean, yeah.
And there's so many things we haven't talked about, like biophilic design is a topic I love and we won't get into, but there's these things that create, it's been in good design for so long, but now there's enough testing and enough science to know really why and how humans connect with things. And so the more we can bring in between good air quality, good health, good materials, good design, and bring it into this thing that people actually care about, that's really the core piece that is going to make a difference.
This is sure to stimulate thinking in a lot of listeners' minds. What's the best way to reach either one or both of you?
Probably valleyhomes.com is our website. And then we have a very active Instagram as well, which is @atoms. And Valley is spelled VALI, and it's plural. So valleyhomes.com.
Okay, I'll put that in the show notes. I hope you do get interaction from the people that are listening to this. I think you will. You've touched upon a lot of things that I can think are on the minds of a lot of people that I interact with on a regular basis. And You seem to have woven it all together and have this calm affect of presenting it. You can make it work. It can work.
Maybe that's us telling ourselves.
We have to tell ourselves this all the time. We both read this book called It Doesn't Have to Be Crazy at Work. It's kind of our business Bible, if you will. And Austin is a magician at finding good productivity systems. And I don't know, we just really, truly love the work we do. And when the results come out and our clients are like basically shouting in joy for getting to live in this space. One of the buyers of Vali Muse I got to meet last week for the first time, and they gave me a tour of their home. Like, it was so funny. I'm like, I know the details of the place. They had to show me every detail, and just seeing their joy. I mean, I was buzzing all day from that.
That is crazy.
It's fun. We got to make this stuff enjoyable, put humans first, not just the building itself in the end, but the process needs to be enjoyable too.
Thank you so much. I'm glad you reached out and we connected, and a pleasure meeting with you. And Lucas, we talked about you've been a customer of TrueTech for a while in your past life, so I appreciate that. And it's a small world, but it's growing bigger, and really like what I heard today and what you're doing, and hope others that are listening will take some action from this.
Fantastic. Well, thank you so much for having us today.
Thank you. This was great.
You're welcome. Hey, thank you for listening to this episode of the Building HVAC Science Podcast. If you like what you heard today, we encourage you to subscribe to the podcast. If you want to get in touch with us, you can reach out to marketing@truetechtools.com, TRUTECHTOOLS.com, and that is the website where you can go to get tools and test instruments for HVAC and building performance trades. As a listener of this podcast, you can get a special discount by using the code HVACBS. In full disclosure, I'm a co-owner of TrueTech Tools, and the Building HVAC Science Podcast is a production of TrueTech Tools Limited. Opinions voiced are those of my guests, my co-host, and myself, depending on who is speaking, of course. I want to thank you for listening to and hopefully following us in the Building HVAC Science Podcast, and we look forward to helping you better understand the buildings and HVAC systems and how they work together. Thanks for listening. Take care.